Okay, we are reviewing transformations as we head into the Regents exam. So let's just talk about some basic transformations. You should know what all of these are. So when you see the capital T, we're translating point A. So -3, -4 translation is going to mean we're subtracting 3 from our x, subtracting 4 from the y. So A prime, remember we always write the image as a prime, is going to be -1, comma, -7. I'm just subtracting both. If this was a plus, I'd be adding, all that good stuff. Now I'm rotating 90 degrees, 180, and 270. So I want to just quickly show you. I would get scrap graph paper, and I would see that the A is here. And I would flip this over. So I would rotate it 90 degrees to the left. So once I have 90 degrees to the left, I would see that I'm at +3, +2. So that is this point. I'm going to pause you real quick. Okay, I paused you, but you're back. You probably didn't even know. So the A prime for the rotation of 90 is 3, 2. If we rotate 180, so I've already rotated 90, I would just turn my piece of paper over again. Remember, so now I'm at -2, +3. And then for 270, I'm just going to do it while I'm here. I would rotate it one more time, and I would be at -3, -2. So that is how you get all of those values for A prime. And again, I'd be writing A prime for these. I forgot to write it for 180. It's okay. You can handle it. What did I say that last one was? -3, -2. Okay. All right. For reflections, if you know your rule, like reflection x-axis, you change your y. Reflection y-axis, you change your x. Reflection y equals x, you switch them. Reflection y equals -x, you switch and negate. If you know those rules, you're good. If you don't know those rules, again, you're going to come back to your graph. And when it says reflect over the x-axis, you're going to say, okay, well, if I'm reflecting over the x, I'm 1, 2, 3 away. So I'm going to go 3 that way. So there would be A prime, et cetera, et cetera, et cetera. So when you do that, you're going to get A prime is 2, 3. Y-axis, your x would negate, so it would be -2, -3. That's a negative. Okay. These are the two I recommend you memorize, because if you don't, yeah, you can count, but you need to know that this is the line y equals x, and you need to know how to count to and from it. So if you can handle that, go for it. But otherwise, I recommend just remembering that if y equals x, you switch them. So this would be -3, 2. So A prime would be -3, 2. And for y equals -x, you would switch and negate them. So you would flip them and change their sign. So it'd be 3, -2. And those are the basics for rigid motions, so ones that keep it the same. Dilations are going to change the size. So with the dilation, you're just going to multiply by whatever number is there, whatever your scale factor is. So in this case, that would be 2, so 4, -6. Okay, -2, you're going to get the same numbers, but they're going to be negative. And what I wanted to point out to you while we were talking about that is that a negative dilation is the same thing as a rotation of 180, because it changes. Like if this was a dilation of -1, it would be the same thing as this rotation of 180, because it changes each sign. So when you dilate by -2, you're not only making it get bigger by 2, you're also rotating at 180. And then a dilation of 3/5, people get scared of fractions, and you really don't need to. Use your calculator if you have to, but really you're just multiplying 2 by 3/5. So that would be 6/5. And you're multiplying -3 by 3/5, and that would be -9/5. If that really is not comfortable for you, use your calculator as a tool. But no matter what, don't you dare give up. Transformations you have to pay a little bit more attention to, and graph paper is definitely helpful. So if we're reflecting over the line y equals 3, the letter B, so I have that here. First of all, we need to know that the line y equals 3 is going to be this line right here that goes through the y-axis at 3. So here's y equals 3, and then you would count 1, 2, 1, 2. So your reflection would be the point -3, +1. So B prime would be at -3, +1. You can also do it algebraically by saying, okay, the 5 needs to get to 3, so that goes down 2. So I need to go down 2 more. So 5 minus 2 is 3. 3 minus 2 is 1. The x's are staying the same. So if I use that same logic with the x, okay, So that means my y isn't being affected. So my x, -3 is going to -4, so that's going down 1. So I need to go down 1 more, and that would be -5. On the graph, I would say, okay, x equals -4. Ooh, that's the wrong graph. X equals -4 is this line right here. And as you can see, you jump over the line. You're 1 away, so you're 1 away. And you're at -5, +1. Okay. Rotation around point A of 90 degrees. So I'm using the point A up here. I just figured I might as well use what's already there. So we're rotating around point A, and that's at 2, -3. Okay. 2, -3. So there's point A again. Okay. You are still going to turn, I just have to put these together so that they turn together. You're still going to turn it 90 degrees like before. Instead of counting from 0, you're going to count from A. So from A, I'm left 8 and I'm down 5. So when I flip it back over, from A, I'm going to go left 8, 1, 2, 3, 4, 5, 6, 7, 8, and down 5. So it's the same process as a rotation of 90 around the origin. It just so happens that I'm using A as my origin instead of 0, 0. That's kind of what it's like. So that's at -6, -8. So B prime is -6, -8. And the last thing we're going to do is a dilation centered at A of 3. Okay, again, we need to pay attention. Dilating by 3 is no problem, but dilating from A3, and this is going to go way off the graph, by the way, but we're going to get over it. Remember, you dilate linearly, okay? So I need to repeat this slope from A to B 3 times. Remember, this first one counts as 1. So I'm going up 1, 2, 3, 4, 5, 6, 7, 8. So I'm going up 8 every time, and I'm going over 1, 2, 3, 4, 5. So that would be 1. I would do it again, and obviously it's going off the graph. So once I do this 3 times, I'm going to be going up 24, because 8 3 times is 24. And I'm going to be going left 15, because again, 3 times 5 is 15. So if I add 24 to my y value of B, I'm going to be at 29. So B prime is 29 for the y. And if I subtract 15, because I was going left 15, I'd be at -18. Usually you're going to have a graph big enough to fit that on. I just picked some random examples, and that's how it worked out. But that's how you dilate from a different point. Okay. They like to ask about rotations. What you need to remember is that you're rotating by 360 because you rotate around a circle. A decagon has 10 sides, so you do 360 divided by 10, you get 36, and then you say, oh no, I think I got this wrong. No, you didn't, okay? You just need to realize that 36 isn't necessarily the answer. You can rotate 36 a bunch of different times. So 10 is not a multiple of 36. But what I'm going to do is I'm just going to look for multiples. So I'm going to do 150 divided by 36. That's not a nice number. 225 divided by 36, also not a nice number. 252 divided by 36 is a nice number. It's 7. So that's why it's choice 4, because 36 can multiply into 252 degrees. Okay. Again, dilations, they want you to remember certain things. Angles always stay the same. So right away, when I see that we're dilating and they want to know what's true, these are gone because my angle measures will not change with a dilation. Scale factor is always image over pre-image, and that's what you got to kind of think of. What is being multiplied by 3 to equal the other thing? My original is being multiplied by 3. If you need to, if this is confusing you, draw a picture. So draw a triangle ABC and make up numbers for it, 1, 2, and 3. Okay, then draw the image afterwards. So make your pre-image, draw your image, multiply them by 3. So this would be 3, 6, 9. And it should be at this point clear to see that 3 times BC is equal to B prime, C prime, not the other way around. Pictures help a lot. Okay, triangle D prime, E prime, F prime has a scale factor of 3/4. If ED is 20, what is the length of E prime, D prime? Notice they come from the same center. That's really, really important with dilations. So, excuse me, the center is O. That's really, really important with dilations. So ED ED is this guy, is 20. Okay, so that is this whole length. This is going to be the same thing because we're talking about the lengths of the triangles, and that was dilated. We're not talking about the lengths of like OE prime. That's something a little bit different. So 20 times 3/4, you would just use your calculator to do that. And remember, with dilation, all you're doing is multiplying. Even if it's a fraction, don't get thrown off. And it gives you 15. That should make sense because we're getting smaller. 3/4 is like 7.75, right? It's going to be smaller. So we get 15 for that answer. If E prime F prime, where are we? E prime F prime is 21. What's the length? So we're going the opposite way. So rather than multiply, I'm going to divide. So I'm going to do 21 divided by 3/4, which is the same thing as multiplying it by 4/3, because with fractions, the opposite of division is, or division is multiplying by the reciprocal. So I do 21 divided by 3/4 or times 4/3, whatever makes more sense to you, and you get 28. If the perimeter is 68, what's the perimeter of D prime, E prime, F prime? Perimeter works the same way. It's also scaled. So you just do this times 3/4. So 68 times 3/4 is 51. So your answer there would be 51, because all of those would be 3/4, so it would work out perfectly. And if angle E is 45, what's the angle E prime? Dilations do not change angles, so it's still 45. Do not multiply your scale factor with your angles. No, okay? On the same set of axes, graph and labeled triangle Q prime, R prime, S prime, after a dilation with scale factor of 3/2 centered at the origin. Use slopes to explain why they're parallel. Okay, again, don't get freaked out by this 3/2 thing. You guys know what you're doing. If all else fails, if you're not comfortable with just going 3/2, just find your points. So R is at 2, 0. So I'm going to multiply both of these numbers by 3/2. When I do that, I'm going to get 6 and 0. So let me just make sure I didn't just lie to you. I did that in my head. I'm going to get 3 and 0. Sorry, doing too many things at once here. So I get R prime is here at 3, 0. And I'm going to write that to the side to make sure that I have all of my work shown. So R prime is 3, 0. Next, I'm going to do S. So S is at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So it's currently at 4, 6. And again, I'm going to multiply both of those by 3/2. So 4 times 3/2 is 6. And 6 times 3/2, I believe, is 9. Good. So 6, 9. 2, 4, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's S prime right there. And then lastly, I'm going to do the same thing to Q. So -2, +2. So those are both going to become 3 and 3. So -3, +3. So there's Q prime. And again, I'm going to write it over to the side. -3, +3. You're going to definitely connect those with a straight edge on the Regents exam, 100%. Okay. So there it is. Okay, so that's my new triangle. And then they want to know, why is Q prime, R prime parallel to QR? You should know that parallel lines have the same slope. They said use slopes. If they were just asking about dilation, you would say dilation doesn't change the angles of things, so the slopes are the same. But you are going to count your rise over run. So this is down 2 over 4. So QR has a slope of -2, 4. Then we have Q prime, R prime, which has a slope of down 3 over 6. When we reduce both of these, it's -1/2 both times. So once you have -1/2 both times, you know that they have the same slope. So you would say parallel lines, that says parallel lines, have the same slope. You would write all of that out. Okay, I'm going to stop this video here. I will make another video for the second half of the sheet.